Next example on Euler's on a L hospital rule. Find limit x tends to 0 x raised to x. So these examples are of the form fx raised to gx. That is, we have to find the limit of the functions of the type fx. That is, the base and power both are function of x. For example, the next problem, cos x is the base and raised to 1 by x squared. So base and power fx raised to gx both are functions of x. And if we substitute limit x as 0, then we have 0 raised to 0, and the 0 raised to 0 is the indeterminate form. So, such a type of examples are solvable by using L hospital rule. But what is the step? Then taking log of both sides. So, suppose y denote this limit x tends to 0, x raised to x, let y is equal to this. Then taking log of both sides. So, log y is equal to log limit x tends to 0, x raised to x. And limit and log are uh, interchangeable. So we have limit x tends to 0, log x raised to x. And log x raised to x is what? X into log x by using log x raised to m rule. Log x raised to m is m log x. So it is x into log x. And if we substitute again x as 0, then we have 0 and log 0 is infinity. So we have 0 into infinity is again indeterminate form. So we reduce the example to the form infinity by infinity or 0 by 0. For that, suppose shift this x to denominator. So we have log x divided by 1 by x. After shifting x to denominator, we have is 1 by x. And then if you substitute x as 0, then log 0 is infinity and 1 by 0 is again infinity. So infinity by infinity form. And therefore we can apply L hospital rule. That is, take the derivative of log x as 1 by x, and derivative of 1 by x as minus 1 by x square. And its simplification is minus x. And then limit of minus x as x tends to 0 is 0. Minus 0 means 0. And so we have log y is 0. But then what is y? Y is e raised to 0. Because log a is b, then a is what? Log a is b, then b, a is what? Log a is b, then a is e raised to b. Okay, or anti-log of b. Okay, log, if we shift log to RHS from LHS, then it becomes anti-log or e raised to b. Exponential function is inverse of logarithmic function. Logarithmic function and inversible functions are inverses of each other. So we have log y 0 means y is e raised to 0, that is e raised to 0 is 1. And what is y? Y means this limit x tends to 0, x raised to x is 1. So limit x tends to 0, x raised to x is 1. The same type problem on the L hospital rule of the type fx raised to gx. Limit x tends to 0, cos x raised to 1 by x square. So if we substitute x as 0, then cos 0 is 1 and 1 by 0 is infinity. 1 raised to infinity is indeterminate form. So taking log of both sides, first write y is equal to this, right? Denote y is equal to limit x tends to 0, cos x raised to 1 by x square. And then taking log of both sides, we have log y is equal to limit x tends to 0, log cos x raised to 1 by x square. Then limit x tends to 0, log a raised to m. So m log a, that is 1 by x square, log cos x. And then log cos x divided by x square. Its adjustment is what? 1 by into 1 by x square means divided by x square. And then if you substitute x as 0, then cos 0 is 1 and log 1 is 0 and 0 square is 0. So we have 0 by 0 form, and therefore apply L hospital rule. So when we can apply L hospital rule, if there is 0 by 0 form or infinity by infinity form. Here we have 0 by 0 form. So apply L hospital rule. So the derivative of log cos x is what? 1 by cos x into derivative of cos x is minus sin x. And derivative of x square is 2x. And that is tan minus tan x, sin x by cos x is tan x divided by 2x. If we substitute x as 0, then tan 0 is 0, 2 into 0 is 0. So 0 by 0 form. So again apply L hospital rule. This negative sign as it is. And then derivative of tan x is what? Sec square x divided by 2. Derivative of 2x as 2. So by L hospital rule. And then if we substitute x as 0, then we have minus sec 0 is 1. Minus 1 by 2 is the answer. and therefore this is the value of log y. Minus 1 by 2 is the value of log y, and therefore y is e raised to minus 1 by 2. And what is y? Y means this, limit x tends to 0, cos x raised to 1 by x square is e raised to minus half. Same type problem, limit x tends to 1, x raised to 1 by 1 minus x. If we substitute x as 1, then we have 1 raised to 1 by 0 means infinity. 1 raised to g, infinity, is indeterminate form. So denote this by y. Y is limit x tends to 1, x raised to 1 by 1 minus x. And it's again the problem of the type fx raised to gx. So taking log of both sides, log y is equal to limit x tends to 1. Log x raised to 1 by 1 minus x is 1 by 1 minus x log x. Log x raised to m rule, m into log x. Then limit x tends to 1, log x divided by 1 minus x into 1 by x means into 1 by 1 minus x means log x divided by 1 by x. And then if you substitute x as 1, then log 1 is 0 and 1 minus 1 is 0. So we have 0 by 0 form right here, in bracket 0 by 0. And then by L-Hospital rule, limit x tends to 1, log x derivative is 1 by x, and limit of 1 is 0 and derivative of not limit of log x, derivative of log x is 1 by x, and derivative of 1 minus x is what? Derivative of 1 is 0 and derivative of minus x is minus 1 by L-Hospital. And then if we substitute x is at minus 1, then we have the limit of the numerator is 1 and denominator minus 1. So 1 divided by minus 1 is minus 1. And this is the value of log y, and then y is e raised to minus 1. That is e raised to minus 1 means 1 by e. And what is y? Y means this, that limit x tends to 1, x raised to 1 by 1 minus x is 1 by e. The same type problem, limit x tends to pi by 2, sec x raised to cot x. These are the problems of the type fx raised to gx, fx raised to gx. And if you substitute x as a pi by 2, then we have sec pi by 2. Sec pi by 2 is infinity, and cot pi by 2 is 0. Infinity raised to 0 is indeterminate form. And the problem is of the type fx raised to gx. So denote first it by y. So let first step write y is equal to limit x tends to pi by 2, sec x raised to, right, like this. Like first step, y is equal to limit x tends to pi by 2, sec x raised to cot x. Then taking log of both sides. Next step we have log y is equal to limit x tends to pi by 2, log sec x raised to cot x. And then use the rule log x raised to m is m into log x. So we have cot x into log sec x, limit x tends to pi by 2 as it is. Then limit x tends to pi by 2, log sec x. If we find the value of this, then cot pi by 2 is 0 and log sec pi by 2 is 0. Sec pi by 2 is infinity and log infinity is infinity. So 0 into infinity form. And therefore we shift this cot x to denominator. It becomes 1 by cot x. After shifting cot x to denominator, we have log sec x divided by 1 by cot x. And 1 by cot x means tan x. So this is now in the infinity by infinity form, because log tan pi by 2 is infinity, log sec pi by 2 is infinity. Sec pi by 2 is infinity and log infinity is infinity. So we have infinity by infinity form, and therefore apply L-Hospital rule. So log sec x derivative is what? 1 by sec x, into derivative of sec x is what? Sec x into tan x. 1 by sec x, right here, 1 by sec x. And 1 by sec x means cos x. 1 by sec x means cos x. And derivative of sec x is what? Sec x into tan x. Divided by derivative of tan x is what? Sec square x. And therefore we have 1 sec x get cancelled. And then we have cos x into tan x by sec x. So simplify this, we have the answer. Okay. Simplify this. Write this, cos x means 1 by sin x. Cos x means 1 by cos x. Here cos x. Tan x means sin x by cos x. Here, sin x get cancelled, and therefore we have sin x by sec x. In this way, solve the remaining example. I will share the answer of this problem through WhatsApp. Next problem is limit x tends to 0, 1 by x minus 1 by tan inverse x. It is not the type of fx raised to gx. So tan inverse x is another notation is arc tan x. Arc tan x means tan inverse x. So arc tan x, arc tan x. Arc tan x means tan inverse x. Arc sin x means sin inverse x. Arc cos x means cos inverse x. So uh, if you find the limit of this directly, then this is infinity and this is infinity. So infinity minus infinity form. So uh, x into tan inverse x as LCM. So we have tan inverse x minus x as numerator. Then we have 0 by 0 form. So tan inverse 0 is 0 minus 0 divided by 0 by 0 form. So when apply L hospital rule, tan inverse x derivative is 1 by 1 plus x square minus x derivative is 1, and x into tan inverse x u into u, x tan inverse derivative of tan inverse x is 1 by 1 plus x square plus tan inverse x derivative of x is 1 by L hospital rule. Then 1 minus 1 by simplification. Simplification. Yes. So if you substitute x as 0, then we have the value of this quantity is 1, this quantity is 1, 1 minus 1 is 0, and the denominator, value of denominator is also 0. So 0 by 0 form, so again I apply a last rule. And therefore the derivative of 1 by 1 plus x square is what? Minus 1 by 1 plus x square bracket square into derivative of x square. 1 plus x square is 2x into 2x. Minus 1 by 1 plus x square into 2x. Derivative of this quantity, and derivative of minus 1 is 0, and derivative of x into 1 by 1 plus x square is u into v rule x, and derivative of 1 by 1 plus x square is minus 1 by 1 plus x square bracket square into 2x plus 1 by 1 plus x square, that is v, derivative of u is 1, plus tan inverse x derivative is 1 by 1 plus x square by L hospital rule. And then simplification. Simplification is what? 1 plus x square, 1 minus, okay, this is only numerator is what, 2x minus 2x divided by 1 plus x square bracket square, here write 2x, and then its simplification, we can directly find the value, no need of this simplification, directly substitute x as 0. So what we have numerator as 0 and denominator as 2. No need of this simplification, directly substitute x as 0. So we have 2 minus 2x means minus 2, 0 divided by this 1 means 0. This value of this quantity is 0 plus this quantity is 1 plus this quantity 1 if you substitute x as 0. So 0 divided by 0 plus 1 plus 1, 0 divided by 0 plus 1 plus 1, that is 0 by 2, answer is 0. So the answer of this problem is 0. Similar problem on the L hospital rule. Limit x tends to pi by 2, tan x by sec x. So infinity by infinity form. Apply L hospital rule. So tan x derivative is sec square x, and derivative of sec x is what? Sec x into tan x. And then cancel sec x, we have sec x by tan x. Sec x means 1 by cos x into divided by tan x means into sin x, tan x is sin x by cos x, but divided by sin x by cos x means into cos x by sin x. Cos get cancelled, 1 by sin x, and if we substitute x as pi by 4, sin pi by 4 is 1, sin pi by 4 is 1. So 1 by 1 is, this value is wrong, I think, sin pi by 4, right? Sin pi by 4, it is not 1. 1 by 1 root 2, and then value, find the value. Next problem, this value is wrong. Sin, substitute x as pi by 4. So write sin pi by 4, value of sin pi by 4 at this place. So we have the final answer. Then the next problem, limit x tends to 0, sin x raised to x. So we have to solve this problem by taking log of both sides. So suppose y is equal to this, and then take log of both sides. Next problem, limit x tends to 0, x cube into log x. So it is in 0 into infinity form. So convert this problem to 0 by 0 form. So shift this x cube to denominator. So it is becomes 1 by x cube. So we have log x divided by 1 by x cube. Now it is in infinity by infinity form. Log 0 is infinity. So it is now it is in infinity by infinity form. So I apply L-Hospital rule. The next step is what? Limit x tends to 0, log x, derivative is 1 by x, and derivative of 1 by x raised to 3 means x raised to minus 3. And its derivative is what? Minus 3, x raised to minus 3 minus 1 means minus 4. And then its simplification, minus 1 by 3 divided by x raised to minus 4 means into x raised to 4 into 1 by x. So we have minus 1 by 3 x cube. And if we substitute x as 0, then we have the 0 answer. So the answer of this problem, x cube into log x is 0. Then limit x tends to infinity, x cube by e raised to x. X cube by e, limit x tends to infinity. So if you substitute x as infinity, so infinity cube is infinity, and e raised to infinity is infinity. So it is in the form infinity by infinity. So apply L-Hospital. So derivative of x cube is what? Next step is what? Limit x tends to 0 is equal to limit x tends to 0. X cube, derivative of x cube is what? 3x square. And derivative of e raised to x is e raised to x. So this right here reason that by L-Hospital rule. And then now if we substitute x as infinity, then we have infinity square is infinity into 3 is infinity. So again infinity, and e raised to infinity is infinity. So again infinity by infinity form. So again apply L-Hospital rule. So limit x tends to infinity. The derivative of 3x square is 6x, and derivative of e raised to x is e raised to x by L-Hospital rule. And again if we substitute x as infinity, then we have infinity by infinity form. So again apply L-Hospital rule. Next step is equal to limit x tends to infinity. The derivative of 6x is 6. Derivative of e raised to x is e raised to x. And now it is what? It is now the limit of numerator is 6. And e raised to infinity is infinity. 6 by infinity. So answer is what? 0. So we have the answer of this problem is 0. X cube by e raised to x. Next problem, limit x tends to 0, tan x minus x by x cube. It is in the form 0 by 0 because tan 0 is 0, 0 minus 0 is 0, and 0 cube is 0. So it's in the 0 by 0 form. So I apply L-Hospital rule. And the derivative of tan x is what? Sec square x minus x, derivative of minus x is minus 1, divided by x cube, derivative of x cube is 3x square. So if you substitute x as 0, then sec 0 is 1. So 1 minus 1 is 0. So and 0 square is 0. So again 0 by 0 form. So apply L-Hospital rule. Limit x tends to 0. Sec square x is what? 2 sec x. Sec x into tan x. Sec square x. Derivative of sec square x is what? 2 sec x. And derivative of sec x is what? Sec x into tan x. Derivative of minus 1 is 0. And derivative of 6x square, 3x square is what? 3 into 2x means 6x. And simplification is this. 2 by 6 means 3. 1 by 3. And sec square x into tan x divided by x. So if we substitute x as 0, then tan 0 is 0. So 0 by 0 form. So again apply L-Hospital rule. So we have the derivative of sec square x into tan x by using u into v rule. Sec square x, derivative of tan x is sec square x, u into v rule. Plus tan x, derivative of sec square x is what? 2 sec x into tan x. Derivative of sec x is what? Sec x into tan x. Divided by derivative of 3x is 3. And then substitute x as 0. So right here by L-Hospital rule, reason by L-Hospital rule. Then substitute x as 0.